all know that soap can propel a leaf boat forward, but I needed some answers about this bizarre technology that's threatening to revolutionize the shipping industry. Alright, no, it's not going to do that, but I did wonder if a boat like this could turn around a bend. If so, how far would it travel when placed on a circular track? What shaped boats work the best? And how far and how fast can it go on a long straight track? Shout out to CuriosityBox for sponsoring this video, more about them later. I think the best way to visualize how this works is using some bubble mix and straws. Dipping the straws in, pulling it out, and the film is held up in tension, pulling on all sides. Placing a straw in the middle to divide the regions, and now focusing only on the forces acting on this metal straw, and you can see that the forces are balanced so the straw doesn't move. However, if you pop the bubble film on one side of the straw, that tension force is gone and there's a force imbalance that pulls the straw to the other side. And here's another example going the other way. Adding soap to water sort of works in the same way because soapy water has a lower surface tension than regular water. You can see this clearly with some classic demos. Placing a few drops of water down and it has a surface that's quite curved. However, doing so with soapy water and it's much more flat. Another way to show this is using a paper clip, which normally sinks in water but can float because of surface tension when carefully placed on top. Adding soap to the water and the surface tension is no longer strong enough to keep the paper clip up and it sinks. You can visualize more clearly how this relates to the boat being propelled using a plate with milk, adding some food dye, and sprinkling some ground pepper on it. Milk does have a lower surface tension than water, but adding soap still decreases it. So adding some soap to the food dye and you create a surface tension gradient that pulls the surface molecules towards the outside of the plate. Adding a few other floating objects and you can see how those objects are moved. Doing this on a larger pan with the same ingredients, and now it's hopefully clear why the leaf is propelled across. That's all great when the leaf is traveling straight, and with the milk instead of water it moves rather slow, so I'm speeding it up here, but I had no proof that it could turn through a bend, and this whole video would be pointless if it can't. So I made a simple turn with Hot Wheels track. To prevent it from leaking, I sealed the holes with plasticine. On the first attempt, the leaf shot off the line, but unfortunately the water wasn't deep enough, so it got stuck right before the turn. After smushing the plasticine down further and replenishing the track, I accidentally dropped a tiny bubble of soap in the water, which wasn't enough to move it, but I was worried the surface tension was weakened, so I went ahead and washed the track again. Trying again, and this time the plasticine wasn't the issue, but rather running into the wall. Also, it's pretty interesting to see this wave that's propagating in front of the boat. I'll show a demo of this without a boat on the long track later. Anyway, trying one more time. This time the leaf started off pretty slow because it didn't get a great start, and then once again got stuck on the plasticine. I was starting to go crazy doing the same thing over and over again and expecting a different result, so I moved on from the unpredictable leaves. I figured I'll 3D print some boats later, but decided to use a piece of styrofoam to confirm that this would work at all before committing to making this video. Placing it on the track and some witchcraft threatened to ruin the experiment as the boat kept turning to the side. What's happening here is actually pretty cool and will be important later, but I just made it smaller and that